All right, let's go ahead and do 5 through 8 on the review or on the worksheet number 3, okay? So we're looking at number 5. What it gave you in the problem is says an isosceles trapezoid with a smaller base of 2, a perimeter of 70, and an acute base angle of 60. So that's one of these angles. Find the area of the trapezoid. Well, it's an isosceles, so I know these two are congruent. All right. Well, it told me that the perimeter equals 70, so I at least have a 2 in there, okay? What we also know is that, well, if I draw this down right here and that down right there, that's 2. So a perimeter equals, or 70, so perimeter, 70 equals at least 2 plus 2, okay? Now let's look at these. I don't know any values about these. I don't know anything about them. What I do know, though, is that it's a 30, 60, 90. So that can be 2x. The height is x. That is x. I'm sorry, this is x root 3. X is the base. Same thing over here. Because any 30, 60, 90 triangle is going to fit into those categories. And I know this is 6 degrees as well because in an isosceles triangle, or an isosceles trapezoid, the base angles are the same. So that's 2x. That's x root 3, and that is x. So what else do I have as far as perimeter? We had 2 right there, 2 right there. Well, I have 2 x's. So let's go plus x plus x. And then what's the rest of the distance around? The legs of the trapezoid, 2x and 2x. So plus 2x plus 2x. All right. So we get, I'm going to move these 4 over and subtract them. So we're going to get to 66 equals x plus x, so 2x plus 2x, so 4x plus 2x, so 6x. So 6x equals 66, x equals 11. What else does the problem say? Find the area. Area equals 1/2 of base 1 plus base 2 times the height. Plug in what we know. Well, area equals 1/2. I know base 1 now because it's 11. So 11 plus 2, which is 13, plus 11 is what? It's 24. Okay? 24 plus my other base, which is 2 times the height. Well, I need to find the height. The height was x root 3. So because the height's x root 3, x is 11 times 11 root 3. Go ahead and multiply that all out. And what do you come out with? You get an answer of 143 root 3. Take a look at that one. And we'll move on. Okay, number 6. All right, number 6, it gave you a trapezoid with a ratio of 2 to 5 to 8 to 5 to sides. First thing, we better draw that trapezoid. So I'm going to draw a trapezoid, and then I'm going to plug in sides. Well, I like 2 up there, I like 8 down there, and I like 5 right there, 5. Now, when we talked about ratios, this is a ratio. That's not the set length, so it's really 2x, 5x, 5x, 8x. That's my trapezoid I'm working with. All right? Okay. Well, now we need to find some stuff out about the trapezoid. It said the trapezoid area is 245 degrees. Okay? Well, area equals 1/2 base times height. Or base 1 plus base 2 times height, right? So let's plug in what we know. I know what one of the bases is. I know area equals 1/2 of 2x plus 8x. I know the other base. What I need to find is the height. Well, let's look at the triangle, okay? Draw our triangles where we can see height. 2x automatically comes down here. So this distance is 2x. Since it's isosceles, because they're both the same, that means that this distance has to be the same as this distance. I have 6x left to split up. So that becomes 3x. That becomes 3x. Okay? So now if I look at this triangle over here, what I actually have is a new right triangle with 5x and 3x. This is any number. Well, if we look at our Pythagorean triples, or we just do it, the Pythagorean theorem, it's a 3, 4, 5. So what is this height? 4x. My height is 4x. Plug that in. Now I'm left with this area equation. We need to multiply it out. When we multiply it out, we go 245 equals, what's 2x plus 8x? 10x. What's 10x times 4x? 40x squared. And we times that all by 1/2, so we're left with 20x squared. Okay? We need to divide by 20, so we got 245 divided by 20 equals x squared, so we're going to square root it. X equals 245 divided by 20. All right, go ahead and type that into your calculator. Should come out to about 3.5. Use 3.5 for x by plugging it in to be able to find out that the height of this triangle this trapezoid equals 14 and the perimeter equals 70. Number 7. Number 7 is probably the toughest one on here, okay? What we need to do is we need to do a lot of algebra. First, let's talk the area of the shaded region, which was everything like that. Or the area of the semicircle, okay, minus the area of my little circle. And these two have the same radius, so I'm just going to call that the area of a circle. Or I'll call it the medium circle. Minus the area of the medium circle, so MC. Okay, that's how I'm going to find the shaded area. It gave you that this was 3. With this problem, we have to make equations, okay? And those equations we need to do is we need to give some values to things, okay? The distance from there to there, or the radius of my small circle is x. So the diameter, or the radius of my big circle equals 2x. And you can go ahead and plug that in all the way across if you want. All right? That is going to be one equation, that the radius equals x plus x, or 2x. All right? The radius of the semicircle, I guess I should say. Okay? The radius of the semicircle equals x plus x. Well, there's another equation I can come up with, and we need to make a right triangle. And you're saying, where in the world do we make a right triangle? We're going to make an isosceles triangle going from there to there. All right. Now, what is that distance? This distance is x plus 3. So the distance, the radius of these half circles, which is x, plus the radius of the small circle, which is 3. So x plus 3 is that distance. Now I want to draw height in here. That height I'm going to call y. All right. So now I have a height of an isosceles triangle, okay? And I also know what all 3 sides are. I'm going to redraw that triangle right off here to the right, okay? That triangle looks like this. X plus 3, x, and y. And it's a right triangle. Okay. I also have another new equation that I just created for the radius of this entire semicircle. And that is going the distance of y plus 3. So the radius of the semicircle also equals y plus 3. Well, these should be equal to each other. So I have x plus x equals y plus 3. I'm going to solve for y. Well, 2x minus 3 equals y. So I know what one of my unknowns is in terms of the other. I need to use that in another equation to solve for it. Well, we're going to go back up to this triangle. We do have an equation here that we know, and that is the Pythagorean theorem, which states that x plus 3 squared, my hypotenuse, equals y squared plus x squared. All right. I now know what y is, so I can substitute that in. So x plus 3 squared equals, parenthesis, y was 2x minus 3, 2x minus 3 squared plus x squared. I need to do some math. I need to do some algebra. X squared plus 6x plus 9 equals 4x squared minus 12x plus 9 plus x squared. All right, all we did was FOIL those out by drawing them out as they would be if it's a binomial or a polynomial squared. So you got to FOIL it out, right? X plus 3 times x plus 3, and actually do first, outside, inside, last. Okay, now I want to combine like terms. Well, I have an x squared over here. I'm going to subtract it. When I do that, so I'm going to minus an x squared. What else I want to do right now? I want to minus a 9. I want to minus a 6x as well. Okay, so I'm moving everything from this side all over here. So when I subtract a 6x or an x squared, I'm going to be left with 4x squared on this side. So the x squared I just took off was right here. So that's gone. That's gone. Minus 6x. Minus 6x, we're at minus 18x. Then minus 9. Well, minus 9. All right. I'm left with 4x minus 18x equals 0. Well, we're going to factor out an x. So x parenthesis 4x minus 18 equals 0. When we do that, we're going to get that 4x minus 18 equals 0 as well. So 4x minus 18 equals 0. Solve for it, we get 4x equals 18. X equals 18 divided by 4, or 9/2. Okay? So we found what x is. Remember that x is the radius of the semicircle is 2x. So the radius of my big one is going to be the area of my semicircle, which is going to be pi times what squared? Well, we're in times 9/2 by 2, which is going to come out to 9 squared. All right. Now the area of the semicircle is going to be half of that, remember? Okay. Minus the area of my little circle. We knew the area of the little circle, which was pi, and it gave us a radius of 3 squared. Minus, all right, the area of my medium circles, we found out that those were x was the radius for that circle. So the radius of that circle is 9/2. So pi of 9/2 squared. So that's your formula. You need to multiply that all out for the area, and you get the area of the shaded region equals 45 pi over 4. You're going to have to combine some like terms and do some math there. But that's how you do it. Let's move on to the last one. This is the shaded region. I know my drawing's absolutely terrible, but look at the one on yours, okay? What we know is that 6 is the radius of this circle. 6 is also half the length of this, okay? And if that's 6 and that's 6, well, then that makes this an equilateral triangle. So I know that there's 60 degrees right there, because every equilateral triangle has 60 degrees in it. All right? Now, in order to find the area of the shaded region, okay, we want to go the area of the circle and the area of the triangle. If I go the area of the circle, I've now done everything in the circle. If I go the area of the triangle, I've done everything in the triangle as well, right? So I need to make sure that I am not overlapping on this area right here or that area right there, okay? So what I actually am going to do is I need to know that this is 60 degrees. If that's 60 degrees, what percentage of that is that in my circle? Well, 60 degrees, 360 divided by 60 equals 6. So I'm missing 1/6 of my circle. So my area of my shaded region, or area of this, equals 5/6 of the area of this circle. Okay? Plus, I'm going to do the area of the whole triangle right now. So the area of the triangle, okay? When I do that, I've now counted 2 things that I don't need, which are these semicircles right here. Okay? Well, since there's 2 semicircles and they're both at 60 degrees of a circle, that's plus 2, or we're going to minus 2/6 of the area of the those circles.